Every time we burn a fossil fuel like coal or oil or natural gas, the burning process emits carbon dioxide into the air. The CO2 from this burning process is actually a fairly significant contributor to the greenhouse gas emissions that industry produces. In this video, we're going to explore ways that we can capture this CO2 and then actually store it deep underground so that it doesn't get to the air. This whole process is called carbon capture and storage, and we're going to get into the detail in just a minute. But first, let's hear a word from our sponsor in today's video. This video is brought to you by Cisco Systems Industry Solutions Group. If you find this video interesting, you can go deeper into the topics of digital operations and security at cisco.com/go/industry. The carbon capture and storage ecosystem is made up of 5 components. Let's start at the beginning. Anytime an industrial process burns a fossil fuel like coal, natural gas, or oil, it releases CO2 into the air. It could be a refinery, it could be a steel mill, it could be a power plant. So there's all kinds of different industrial plants that emit this CO2 from fossil fuel consumption. So that's where it all starts. Now, typically the way this happens at an industrial plant is the burning process happens in one part of the plant. This burning chamber doesn't just release its exhaust into the air directly. It typically has some type of exhaust flue that's routed outside of the building and then goes into a large smokestack like you see on a lot of these industrial plants. And then the smoke comes out of there into the atmosphere. And so what's done in most of these locations that need to do carbon capture is they will actually insert a carbon capture process into that exhaust flue. So when the exhaust comes off of the burning chamber, it actually passes through this CO2 capture process. Now there's a lot of different types of capture processes out there, and I'm not going to get into the details of that in this video, but just I guess remember that that's where the capturing process starts. We can actually remove up to 90% of the CO2 from that exhaust, which is actually quite a significant reduction. Now that's quite a costly process today, and we'll talk a little bit more about that later. But really, this is the bulk of where the technology exists for carbon capture and storage. Now it's very rare that the industrial plant that actually needs to have this gas captured, that it also has a place to store it permanently. And so as a result, there's a whole ecosystem that's developed around this carbon capture and storage process. So the actual capturing part happens at the industrial plant, but then it needs to actually send the CO2 somewhere. It doesn't typically store it on site, although sometimes there might be a temporary storage tank on site. Eventually it makes its way down a CO2 pipeline to either directly to the storage site, but more often it will actually be transported into some other temporary storage facility. Now, if you take a look at how this works from the temporary storage facility and on, this is where it actually resembles a lot of the existing oil and gas processes today. So in the oil and gas gathering and production and processing path, all the way from where it's extracted from the ground to where it gets turned into an oil and gas product like plastics or gasoline or diesel fuel, that happens at the end. What typically happens is it gets pulled out of the ground and then it gets put in a pipeline, it goes into temporary storage at various hubs in the process, and then it continues on to where it's being processed. So the carbon capture and storage process is very similar. It has the pipeline that goes from where it's captured to these hub locations that are located at central locations where all of the feed CO2 can come into these temporary storage facilities. Then these hub companies can actually make deals with various storage facilities, and then the gas is transported from those hub locations to the permanent storage locations. And that's where this next pipeline comes into play. And then eventually it ends up in the last step, which is the permanent CO2 storage facility. So you can see that these 5 steps all work together to create a whole carbon capture and storage ecosystem. And you've also recognized now that that whole ecosystem actually resembles a lot of what happens today in oil and gas. So as we review, it becomes obvious that really the only step in this whole ecosystem that's brand new to the industry is this carbon capture piece at the industry facility. And so what you'll notice is if you read some of the articles about carbon capture and storage, almost all of the focus is on this capture part. And that's where actually most of the money is being spent from a research perspective. Today, if you were to implement this whole process, 2/3 of the cost of the whole process would actually be in the capture part at the industry facility. And so that is really where the focus of the research needs to be in order to make it affordable. I hope that helped you to understand the whole ecosystem a little bit better. How do the economics of this whole system work? Well, today is maybe a little bit different than where it will be maybe 10 years from now or more. Today, what happens is a lot of oil producers actually use gas and inject gas into the ground in order to enhance the oil recovery as they pump it out of the ground. And so what's been happening today is any industry locations that are capturing the CO2 actually sell it to these oil companies and production companies that are using it for enhanced oil recovery. And so the oil producers are actually paying the industrial companies who are capturing the CO2 to offset some of the cost of the capture process. At some point in time, we'll see that there's going to be a need for long-term storage sites to be established that don't use it for enhanced oil recovery. Now, some of that is already happening, but these storage sites, they really have no benefit of storing the CO2. And so they need the suppliers of that CO2 to actually pay them to store it. Now, that comes from the pipeline company, but the pipeline company doesn't have any inherent benefit in transporting the CO2, so they're going to want their costs covered by somebody upstream as well. The same could be said for the CO2 temporary storage facilities, or hubs as they're called, where all of the CO2 is gathered temporarily before it's sent to the storage. And so as you work your way back through the 4 steps after carbon capture, all of these other 4 steps are actually net costs that need to be covered at the beginning of the process. So what would motivate an industry to actually pay all of this money for this capture and storage? Well, there's a few things. First of all, there's a lot of momentum building for significant carbon taxes to be put into place by multiple different types of governments. And actually, this could become a global type of revenue base for governments, where they're able to tax for greenhouse gas emissions. And so one of the big contributors to paying for this whole system is avoiding those carbon taxes. So that would be the first one, carbon tax avoidance. The second one is that nobody really likes a company that's spewing CO2 into the air, right? And so the other thing that really starts to benefit these industries when they capture the carbon dioxide and are able to store it, they're able to actually talk about themselves as a cleaner company. And so that PR effort is the second reason why companies would want to capture. There's a monetary value to them to be seen as a clean company. The third component is actually how the products are priced that come out of these industrial facilities. So let's take steel for an example. So a steel mill would have a standard market price that they would get for steel on the market for standard processes that everybody uses. And now what we're starting to see is companies that are transitioning their processes to cleaner processes that don't emit greenhouse gases into the atmosphere are able to charge a premium for the steel that comes out of their mill. And people would pay extra for this clean energy steel that doesn't have the same greenhouse gas record with it that standard steel production does. And so they would be able to gain some benefit out of the better pricing of their material as clean products. So that puts us up to 3 different reasons. So avoiding carbon taxes, better public relations, and better product pricing. And then there's a 4th one that we're starting to see come into play, and that is the legal risk of continuing to put greenhouse gases into the atmosphere. We're starting to see legal cases being built around the effects of climate change. And that some organizations, whether it's the fishing industry or whether it's any kind of industry that's making its livelihood in ecosystem that's being affected by climate change, these groups, these industry groups, are actually starting to build class action lawsuits against the heavy emitters of greenhouse gases. It's very reminiscent of what we saw the healthcare providers filing lawsuits to the big tobacco companies a number of years ago. We're starting to see a similar sentiment grow in the legal community. And so that puts us up to 4 different really good reasons why a company would want to do carbon capture. So the benefit that this company would realize from avoiding carbon taxes, improving their public relations, getting better prices for their product coming out of the industrial factory or mill, and then avoiding any kind of future legal risk. Those 4 items have to equal more benefit than the cost of actually capturing the CO2 and then actually paying for transporting it to a permanent storage location. Hopefully that helped you to understand the whole process and who pays for what a little bit better. If you enjoyed this video, I encourage you to like it and subscribe to the channel. I'm going to be doing more videos on various components of this ecosystem, specifically around the carbon capture component for sure. In the meantime, please enjoy a few other videos, including the one that's actually on the screen right now.